Hello everybody, it's Yuri Goman. Today I will teach you how to draw UML sequence diagrams. UML sequence is a behavior diagram that shows how classes or objects in the system interact with each other over time and the order of those actions. This diagram provides a detailed view of a specific process within the system on a low level. The popular question is why business analysts must learn sequence diagrams if they feel so similar to activity diagrams or flowcharts. The answer is that those diagrams have different focuses. The activity diagram shows a workflow and is used to model business processes and flows in the system. A sequence diagram, on the other hand, focuses on displaying how objects communicate with each other through messages and in specific sequence for a particular use case or operation. They also show how long each object is alive and what is typical time for performing each operation. The first thing to understand about sequence diagrams is that they have two dimensions. The first dimension, the vertical axis, shows time. Time flows from top to bottom in these diagrams, and events at the top occur before events lower down. The second is the horizontal axis, which shows objects and participants. This two-dimensional structure allows us to show both which objects are involved and when they interact. A lifeline represents the existence of an object during the interaction being modeled. It's drawn as a vertical dashed line under each object at the top of the diagram. When an object is created during the interaction, its lifeline starts pathway down. If an object is destroyed during the interaction, its lifeline ends with an X. Lifelines help you visualize when objects are active and when they cease to exist within a particular scenario. The activation bar, also called focus of control, shows when an object is performing an action. The length of the activation bar indicates how long an object is active or processing a message. In advanced diagrams, you will find time in milliseconds, showing the total time activation bar is alive. Now, when the canvas is set with lifelines and we understand activation bars, we can start having fun and adding call messages. The call message is depicted as an arrow pointing from the sender, the object initiating the call, to receiver, the object receiving the call. First is synchronous and asynchronous. A synchronous call requires the sender to wait until it gets a response before continuing execution. This message type is depicted with a solid arrowhead pointed from one object lifeline to another. An asynchronous call, on the other hand, allows the sender to continue without waiting for a response. This type of message is shown with an open arrowhead. For example, a synchronous call might be used when querying a database for information, but you need to wait for data before proceeding. An asynchronous call could be used when sending an email. You don't need to wait for confirmation before moving on. A return message indicates that an object has completed processing and is returning control back to another object. For instance, you'd expect a return message with the result after querying the database. Sometimes an object may need to call one of its own methods or perform some internal action. This is called a self message and is represented by an arrow looping back onto the own lifeline. If object B needs to perform some initial validation before responding to another object, it will send itself a self message. For example, if shopping cart needs to validate whether all items are still available before proceeding with checkout, it could send itself a self message indicating this internal check. A create message shows when one object creates another during an interaction. This is represented by an arrow pointing from one object's lifeline to a new lifeline. For example, in an e-commerce system, when a customer places an order, we might see a create message where the system generates a new order object. A destroy message indicates when an object is terminated during an interaction. For example, once payment has been confirmed and processed successfully, if there is no further need for temporary session data like card session, we could destroy this session using the destroy messages marked with an X. Finally, there are lost and found messages. A lost message occurs when a message leaves your system without reaching its intended destination. In contrast, a found message enters your system without any known origin, perhaps coming from some external system or user input. These are less common but useful in certain scenarios where external systems interact with your software in unpredictable ways. For example, when the system sends data out via API but doesn't receive acknowledgement from external services, this would be captured as lost communication within our sequence diagram model. Sometimes interactions include conditions or loops that require special handling in sequence diagrams. UML provides combined fragments for those scenarios. Those fragments allow you to model complex interactions like alternative paths optional behavior loops, and parallel actions. The out fragment represents alternative paths based on conditions. For example, if payment succeeds, one path is taken. If payment fails, another path is followed. The opt fragment shows optional behavior that only happens if certain conditions are met. This is useful for modeling features that may not always be executed depending on user input or system state. For example, if the customer applies a discount code during checkout, we can use an opt fragment to show this optional behavior. If no discount code is applied, the interaction part is skipped. The loop fragment represents actions that repeat multiple times. This is useful for modeling iterative processes within your system. For example, adding multiple items to the cart would be represented using a loop fragment, since this action can occur repeatedly until checkout. The parallel fragment allows parallel execution of actions, which is useful when multiple tasks happen simultaneously. For example, if inventory updates and payment processing happen simultaneously during checkout, we could use a POR fragment to represent these parallel actions. Now that we've covered all the elements in detail, let's create an example of UML sequence diagram.
For this video, I selected a typical example of online shopping experience. To model this shopping experience, you will need the following lifelines or elements in the diagram. The first element is user or customer, the person who enters website and buys stuff. The second is a login module. It's not mandatory since you can buy stuff even without your account. At the same time, this is a typical feature and I would like to show you how it works in sequence diagram. The next thing is product catalog. In our case, this lifeline represents all the features related to searching and viewing products. The next one is shopping cart, which is self-explanatory, and checkout and payment. The reason I have two lifelines and they are not together is because payments in this case is a third-party solution. We begin modeling from the moment when the user tries entering the system. For that, user enters their credentials and system validates them. This is where we can use our first known combined fragment, which is called alternative. It represents two different variations of the same flow depending on successful or unsuccessful credentials validation. In case of successful validation, system asks user to provide an OTP, one-time password, and validates that OTP, and if everything's okay, we return user to the logged in page. In this diagram, I skipped two moments. First is the interaction between the login feature and some third-party solution that requests an OTP for the user. In this case, this will overcomplicate the diagram, so we just assume it happens. Another moment is OTP validation. Basically, I need to add another alternative here showing what happens if OTP is not validated successfully. But for the sake of your time, I skipped that point and we just return user to the logged in page in successful validation case. If credential validation failed, we return failed message and user can try again. After we get into the system, we get to the loop combine fragment. Basically, the flow in which user search for the products, system fetches products and returns the list of them to the user. User selects and views some product and system shows the product details. To make things more interesting, I will throw in an optional combine fragment to show that adding product to cart and receiving successful adding message is completely optional. User don't have to do that. At the same time, in this diagram, we assume that the user will do that because we will continue with shopping cart and checkout. After our user added all the products they wanted into the cart, they need to review it. To do that, they request the shopping cart and it returns its content. We assume that our clients may modify their shopping cart when they review it. That's why we throw in this optional combined fragment as well. We could have used a loop here as well, but it will overcomplicate the diagram because the loop happens for the same optional combined fragment, for the same elements. That's why I skipped the loop here, and the next step is proceeding to checkout. During the final steps, the system returns the checkout form. User enters their shipping and billing information, system saves it, and basically returns the message that the information is saved. After that, the user enters their credit card information and pays. Our system sends payment request to the payment agent, which validates the credit card information, and if everything's successful, it charges the credit card. Then the system returns the success payment message, which our system shows to the user after redirecting them back to products page.
UML sequence is one of many cool diagrams that you can learn and use in your projects. If you like this video, be bold to subscribe and then check out this video to learn about state machine diagrams or view the entire UML tutorials playlist. Thanks for watching this tutorial. I hope that this video was helpful.